Okay. So, how are you guys? How's it going? So, I'm second year mechanical engineering student at NIT Kurukshetra also. Currently doing DSA. I have a fear that I'll be able to get a good job at good tech company. Okay. Second year mechanical. So you have a lot of time, Akash. You don't have to worry about it because uh, a lot of students of mechanical I know, like my friends as well, who have just have done the DSA and just went into the IT industry, and they are doing very good. See, on campus, maybe there may be some companies who will not allow you to sit in the campus placement because they only want IT CSE students, or they want EC student maximum. They don't want mechanical student, but off campus you can apply, and companies just see your potential. You're like, if you know, have the knowledge, and you will be selected. There's no worry about that. Maybe I think you should start doing some internships as well at several firms, so that will also help you in your job, that you have some experience. Okay, so now let's start. So hello everyone, my name is Rahul Singla. I am SD1 at Innovator. I was ex-mentor and SD at Geeks for Geeks. I mentored a lot of students from major IITs and NITs. I cracked companies like Grofers and Swiggy. Subjects I am taking here are Core Java, OOPS in Java, DSA in Java, and then maybe competitive programming in Java as well. And also planning some frameworks in Java. Okay. So also we have this career as a developer subscription. So in this career as a developer subscription, you have a lot of shows covered, which is based on placement in top product and service based companies, beating the odds to get a good placement, live problem solving sessions, over the weekend projects. A lot of these things are there. Okay. And also mock interviews will be there, like you will get to know how actual interview goes, what types of questions are asked, what is the pressure, right? Because if some student is giving the interview in front of all of you, so you will know that how much pressure is there when someone is sitting in front of you and he is asking the questions. And also you will get to know, like, there will be a lot of pre-placement talks as well, so that you will know about the HRs of different companies. And then you will get to know that when to apply to which companies, how to get internships, and a lot of shows are there in this career as a developer subscription. And it is just for 999 for the whole year. And if you want some discount, you can get it with my code rsingla10. You will get 10% discount, and you will get it for 899 only. Okay. Now coming to college projects. So college projects is one of the shows present in career as a developer subscription. It is taken by Raja Vikramaditya, who is Striver, if you know him. And also this show is live every Friday night at 10 p.m. It is also a part of career as a developer subscription. And also college projects is something we all know that it is very difficult to think that what we should do and what features we should put in our projects, and also but is it enough to get an internship. Okay, so all these doubts will be cleared by him in this show, and it is live every Friday night at 10 p.m. Okay, and if you now also take this subscription, you will get all the recorded lectures as well. Now coming to the CodeChef Apprentice. So this is also a part of career as a developer subscription. It is taken by Sai Avinash, who is SD at Google, 7-star at CodeChef. So he is already a 7-star at CodeChef. He will tell you that how to become 7-star at CodeChef, what practices he has followed, and also he will solve couple of questions. You may also get some chance to go on his show and interact with him. So a lot of opportunities also there in this CodeChef Apprentice. It is also a part of career as a developer subscription. So you can take career as a developer subscription for 899 only if you use my code. Otherwise you will get it for 999 for the whole year. Okay, and this show is live every Saturday afternoon at 2 p.m. Now most important thing, just go and join this Telegram channel, because without it you will not get all the updates what is going on all the channels of Unacademy, right? Now also go like, share and subscribe, because a lot of students should know that what courses are going on here. They can also get benefit from all the free courses going on here. So just go like if you like it, share if you want to share, like, and subscribe because you get all the information. So just do that as well, right? So searching and sorting, we were doing searching and sorting, and today we will do some questions on that. So the questions that we are going to take today is aggressive cows. If you have listened about, like, heard about this question, it is very famous question, aggressive cows. We will see the rotation point, we will see the transition point as well. Okay, so let's start. So the first question we can take is aggressive cows. Okay, so this aggressive cows question is a part of, I'll say, let's search. Okay, let's search this question, aggressive cows, aggressive cows, and we will get the question. Okay, this is that famous, aggressive cows binary search, right? So you will get the first link of Spoj, okay, and you will see the question here. Let's see the question. What does the question says? So the question says that there is a farmer John who has built a new long barn, okay, with n stalls. Okay, so let me just along with it tell you guys what is going on. So there is a farmer John who has built a new barn with 2 to n stalls. There is a barn, okay, there are some stalls in it. These stalls are located along a straight line in position x1 to xn. So these stalls are located in a straight line. Okay, so if this is first position, this can be 5, this can be 9, but they are in the straight line, and it will only be between 0 to this 1 2 3 10 to the power 9. Okay, this is the thing. Now his C cows, he has some cows as well. Okay, in the and what he wants to do is, with his C cows, don't like this barn layout. They don't like that he has taken this barn and this layout. They don't like it and become aggressive. The cows that he has, let's say these are the cows he has, 1 and 2. So they become aggressive in these stalls, right? Because they don't like the layout of it. Now each other once put into a stall, right, to prevent the cows from hurting each other. So if the cows are very close to each other, they can hurt each other as well, right? So let's say one cow is here and one cow is at the second position. So they can hurt each other because they are very aggressive. The name of the question is aggressive cows. So because they are very aggressive, so we cannot put them very close to each other. Okay, we want to put them as away as possible. So to prevent the cows from hurting each other, FJ wants to assign the cows to the stalls such that minimum distance between any two of them, that means let's say minimum distance between these cows, should be as maximum as possible. What does that mean? That if you have two cows, he wants to put them as far as possible. Okay, whatever the question says that you will be given with an array. Okay, you will be given with an array in which you will be given with the positions of stalls. Let's say 1 2 5 9 12. So let's say this is the positions of the stalls, and we know that the stalls are in the straight line, right? And there is a barn, and you will be given with some cow as well. Let's say 3 cows you are given with, and your position of stalls are this. So position of stalls starts from 0. So first stall will be at first position, second will be at second, another will be at 5, another will be at 9, and another will be at 12. Okay, now you have to put these 3 cows in these locations 1 2 5 9 and 12. You can put these 3 cows at any positions you want, but the condition is you have to put them as far as possible. That means the minimum distance between 2 cows. Let's say I have put this C1 cow here and C2 cow here and C3 cow here, right? So we have to see that the minimum distance between any 2 cows should be as large as possible. That means any 2 cows should be as far away as possible in these given positions. Okay, you have to solve this question now, right? So what is our task? You are given with the positions of stalls, you are given with the number of cows. You have to put these number of cows in these positions as far as possible. Okay, this is the question, right? So anybody has any doubt in the question? Like, have you got all of you have got the question? what we have to do is, let me just explain here as well, right? No, it is not necessary. You have to put them as far as possible. It is not necessary that you have to have the equal distance between them. No. So let me take an example and make you understand. So let's say this barn is of 0 to 10 to the power 9. Okay, this is the distance that you are given with, and let's say you are given with positions. The stall is here. The stall is at 3 position. One stall is at, this is 1. This is 3. This is, let's say, 9, 12, and 15. Let's say these are the positions of stalls, and let's say you have 3 cows. You have 3 cows. So what you have to do is you have to put these 3 cows as far as possible. Okay. So if I put first cow here, let's say C1 here, second cow here, C2 here, and third cow here. Okay. So I think they are as far as possible. So 9 minus 1 is 8 distance, and 15 minus 9 is 6 distance. So is there any other way I can put these cows so that their distance is maximum, like they are as far away as possible? Is there any other way? So we have to think of all the ways. We have to think all the ways. So here we have only 5 positions, right? So we can see that I will put it here, I will put 1 here and 1 here. Okay. So, and we will see the distance as well. But if there are hundreds of cows, thousands of cows, so you have to think that where to put which cow, right? And maintaining this constraint that their distance should be as far as possible, because if we put them close to them, they will become aggressive. That's why the name of the question is aggressive cows. Aggressive cows. Okay. So I hope the question is clear. Then we will move to the solution. Anybody has any doubt in the question? So this is one of the very good questions. It is on Spoj. Okay. And let me just go down and see one of the test cases. See, so test cases here, you can see here you are given with these 5 positions: 1, 2, 8, 4 and 9. Okay, so these are the positions given to you. They are not in sorted order. First of all, we have to sort them. Okay, 1, 2, 4, 8, 9, so that we get the correct order, like they are in the ascending order only. It is given in the question that they are in ascending order only, right? Because they are in the straight line. So the position of 4 will be before the 8, not after the 8, right? So now we have got these positions, and you are given with 3 cows. Now you have to put these 3 cows as away as possible in these locations. Okay, at these locations, right? Now let's say I put 1 cow here, C1 here, C2 here, C3 here. So what is the minimum distance between them? So 8 minus 1 is 7, and this should be 4, 4 minus 1 is 3, and 9 minus 4 is 5. So minimum distance is 3. So the answer will be 3 here, right? You can see here the answer is 3, right? So now let's solve it. How we can solve the question? Let's see that, right? So we will take the same example so that we know the answer as well. So 1, 2, let's write it here. 1, 2, next is 1, 2, 8, 4, 9. Okay, 1, 2, 8, 4, 9. Okay, just the question is aggressive cows. Okay, the question is aggressive cows, in which what you have to do is you are given with some positions. Okay, in the form of array you are given with some positions, and you have to put the cows in these positions, in these given positions, and at the distance as far as possible, because they become very aggressive when they are put together. So you have to put the cows as far as possible. Okay, as far as possible to other cow. You will be given with the number of cows, you will be given with the array of where you have to put the cows. Okay, now you have to find the minimum distance where you can put the cow and they will not be aggressive. Like you have to put them as far as possible, and you have to find the minimum distance, like the minimum distance you can put them away. Like here in this case, when you have 1, 2, 4, 8 and 9, in this case what is happening? So 1, 2, 4, 8, 9, 8 and 9. So if I put 1 cow here, 1 cow here, 1 cow here, okay, these 3 are the cows. So the distance, minimum distance will be 1 here and 2 here. So minimum will be 1. The answer will be 1. But can we find the better solution? That means can we put the cows more far away? So next, let's try the next one. So we can put C2 here and C3 here, right? In this case, 4 minus 1 is 3 and 8 minus 4 is 4, right? In this case, minimum distance is 3. Okay, the answer will be 3 in this case. Now let's say, can we put them as more far? Yes, we can. So let's make C3 here. So in this case, 4 minus 1 will be 3 and 9 minus 4 will be 5. So still the minimum distance is 3. The answer will be 3 only. But you have put them as far as possible. So you will pick the 9 position, not the 8. You can put take 8 position as well. But because in this question you have to return the minimum distance, not the maximum one, right? So the answer will be 3. You have to return the minimum distance, right? I hope the question is clear. Now let's move to the question, solution, right? If anybody has any doubt in the question, just ask right now, because we will move to the solution now. Okay. So let's take the same example. 2, 1, 2, 8, 4 and 9. First of all, first thing you have to do is you have to sort the array. Why you have to sort the array? Because in the question it is said that the positions are in the straight line. So 4, if it is given afterwards, it will always be considered before, right? So the position will be like 1, 2, 4, 8 and 9. Not 8 will be before, after, like 4 cannot be after 8. Okay. So you have to sort this array first of all. So it will be 1, 2, 4, 8 and 9. Now what you have to do? Now you have to think. Okay. So here we know that the maximum distance, let's say cows you are given with is 2. Okay. So the maximum distance between 2 cows, what can be the maximum distance? The distance can be 9 minus 1, 8. Okay. So maximum distance can be 8 only, right? If the cows are 2, I can put 1 cow here and 1 cow here, right? The distance cannot be greater than that. If I have to put only 1 cow, what do you have to do? You will just go here, okay, and we will put the cow here. You can put it anywhere actually, right? If you have only 1 cow, because it will not be aggressive with any other cow, right? So now what we will do is, in this case, we have got that the maximum distance between any 2 cows can be only 9, right? Maximum distance between any 2 cows can be 9 only. It cannot be greater than that. Okay. What will be the distance if we take 10 cows? So see, if there is 10 cows only, you cannot put them. You are not given with the position. So that will be the edge case, right? You can put only 1 cow in 1 stall, not more than that. Okay. So now let's move forward. So the maximum distance that you can take is 9 only, which is the maximum distance, right? Number of cows, number of positions. Yes. Number of cows is greater than equal to number of positions, then we will just return. We don't have to do anything, right? So now what we will do is, we know the distance, maximum distance is 9. So what we will do is we will use binary search. Okay. How we will use binary search? So we will take the lower limit as 0, okay, and the larger limit as 9. So Ravi Kumar, okay, can you please explain again the question you want me to explain, Ravi? Actually I have explained it a lot, many times. Okay, so let me explain it last time. So in a simple words, so what you have to do is, you are given with an array in which you are given with the positions, okay, and you are given with the number of cows. Let's say the number of cows is 3, right? What you have to do is, you have to put these cows in these positions only, as far as possible. The name of the question is aggressive cows. Okay, you can find it on net as well, aggressive cows, right? So name of the question is aggressive cows. So you can take 1 as well, there is no problem, you can take 1 as well, but for the safer case, we start from 0, because in binary search, even if you take 1, even if you take 0, it is okay, right? Because we will reach to the solution. You can take 1 to 9 as well, you can take 0 to 9 as well, right? But the distance, we are talking about the distance here, so 0 makes more sense, right? Not actually, it doesn't make much sense, but we start with 0, or you can start with 1, anything, right? So 0 to 9, let's say you are given with this limit 0 to 9, the maximum distance can be 9 and minimum distance we are considering that it can be 0, but we cannot put 2 cows in 1 position, so it will never be 0, right? We can start from 1 as well. Okay, now what we will do is, we will use binary search here. So let's say this is our starting point and this is our ending point. Okay, this is our ending point. So what we will do is, first of all, as we do in binary search, we will find the mid. So start plus end, 0 plus 9 by 2, it will be 9 by 2 is 4. Okay, 9 by 2 is 4. So 4, but now what we will try to do, see in question what we will try to do is, now you got a distance 4. Okay, now what you will try to do is, you will try to find out 3 positions in this array. You will try to find out 3 positions in this array in which the minimum distance between any 2 positions should be greater than 4. That means what I am trying to say here, if we are taking 3 cows, okay, if we are taking 3 cows, so we want to put them as far away as possible, right? So if I take, let's say 1, okay, and let's say next distance can be 8, so we cannot choose 3 positions from this array in which the minimum distance, at least minimum distance can be 4. Okay, so minimum distance between 2 cows should be 4. So here this 4, here what we have calculated with this distance 0 to 9, and we have calculated the mid. So what we are trying to do here is, we will try to find out that if we can find C number of cows, whatever the cows are given here, let's say 3 right now, 3 number of cows in this, 3 number of positions in this array where we can put these 3 cows, okay, in which the minimum distance between any 2 cows is at least 4, okay. We will try to find out those positions, okay. So let's try to find out that. So in this case, if I take 1, okay, then next position 2 minus 1 is 1, so we cannot take 2 as the position because distance is less than 4, okay. Now we will go to this position, 4 minus 1, this is 3, so we cannot take this position as well because the distance should be greater than or equal to 4, right? So now I will go to 8, so 8 minus 1 is 7, so I can take this position. Let's say I have taken this position 8, right? Now distance between these 2 positions is greater than equal to 4. Now we have to see that the next position that we will take should also be at distance 4 far away from 8. We want to find that position now. But when we go to 9 minus 8 is 1. So we cannot take 9 and no more positions are there. So we can only choose 2 positions if we take minimum distance as 4, right? If we take minimum distance as 4, we can only choose 2 positions. That means only 2 cows we can put there in these 2 positions. But we have to put 3 cows. So 4 cannot be our answer, right? 4 cannot be our answer. And also if 4 cannot be our answer, so greater than 4, from 4 to 9, all the numbers cannot be our answers, right? From 4 to 9, none of the numbers can be our answer, okay? Because if we increase the distance, this will also increase, right? We cannot choose a position that way. If we take 5, again we can choose only 2 positions, 1 and 8, right? Same way, if you guys are getting it, that greater than 4, we cannot choose any position now. Why we are not taking 9, sir? We are taking 9, 0 to 9. We have taken from 0 to 9, and when we find mid, it will be 0 to 9, 0 plus 9 by 2, which we will get as 4. Okay. Now we are checking for 4. If we can find 3 positions in this array in which the minimum distance between 2 positions is 4, we are trying to find out those 3 positions, but we cannot find it with the help of 4. So what we will do is, we will go, instead of going on right, we will go left. We will go left side. Okay, that means we will now try to find out the solution between 0 to 4. Okay, now again, as in binary search, what we do, we find the mid. So 0 plus 4 by 2, it will be 2, right? Now we will try to find out that if we can find 3 positions in this array in which the minimum distance between 2 positions is at least 2, so let's try that. So 1, if we take 1, then we will go to 2. Okay, so 2 minus 1 is 1, which is less than equal to 2. That means the distance between 1 and 2 is not 2, right? So we cannot take this position. So we will go to 4. So 4 minus 1 is greater than equal to 2, right? So the distance, we are talking about the minimum distance here. So here we are calculating the minimum distance. So distance can be greater than or equal to 2. Okay, so 4 minus 1 is 3. So we can take this position. That means it is greater than equal to 2. So 4 can be one of our answers, right? So we have chosen 2 positions now. Now we will move forward. So after 4, we will try to find out 8 minus 4. 8 minus 4 is 4. So we can take this position as well. So we can see that we have found 3 positions, right? We have found 3 positions in this array, where the minimum distance between any 2 positions is at least 2, right? We have found that solution. That means 2 can be one of our answers. 2 can be one of our answers. It is not our answer. It can be one of our answers, because we want to maximize the distance, right? We want to maximize the distance as far as possible. 2 can be one of our answers, but now what we will try is, we know that if 2 is our answer, so 0 to 2 everything will satisfy. From 0 to 2 everything will satisfy. Now we have to go on the right. Okay, now we have to go on the right. So from 0 to 4 we were at, now we will go from 2 to 4. Now we will go from 2 to 4. Now we will try to find out our solution between 2 and 4. Okay, because already, so let me draw it here. From 0 to 9, first of all we found 4. So 4 was not our answer, so this part was rejected. Now between 0 and 4 we found 2. Okay, for 2 we found that there is an answer which exists. So now we will go on the right and we will try to find out like more distance, like as far as possible they should be. So I will try to maximize the answer. Okay, so now my range is left with 2 and 4, between 2 and 4. So now let me erase it. It has become a little clumsy. Okay, let me erase this part. So now we will find the answer between 2 and 4. Okay, just a second. Let me just erase everything and let me write it again. Okay, so let me, first of all we took from 0 to 9, right? The array was 1, 2, 4, 8 and 9, right? Now in this part we have taken mid. 0 plus 9 by 2 was 4. So now 4 was not our answer, because we cannot choose. C is 3 right now. Okay, so we have to choose 3 positions for 3 cows. Okay, so 4 was not our answer because we cannot choose 3 positions here in which we can put these 3 cows, in which the minimum distance is at least 4. We cannot choose that. So we went on the left side. Okay, because greater than 4 cannot be our answer. Now from 0 to 4 we found mid, which is 2. So for 2 we were able to find 3 positions here, which was 1, 4 and 8, in which we can put our 3 cows. Okay, that means 2 can be one of our answers. So we will store 2 somewhere. So let's say in the count we have stored 2. Now we will try to maximize the distance, right? The question is we want to maximize the distance as much as possible. Okay, so we will go on the right now. So that means now the range is between 2 and 4. Now again we will find the mid will be 2 plus 4 by 2 is 3. Okay, so the range is, mid is 3. So now we will try to find out if 3 can be our answer. 3 can be our answer only when, if we can choose 3 positions from this array in which the cows are at least 3 distance apart. So let's try that. So let's take 1. Okay, then 2 minus 1 is 1, which is less than equal to 3. So we cannot take this position. So we will move forward. We will move to 4. Now 4 minus 1 is 3. Okay, so it is exactly 3. We can take 3 or greater than 3. Okay, so we can take this position. Now we will move forward. So 8 minus 4 is 4, which is greater than 3, right? Which is greater than 3. That means we can take this position as well. So we have found that 3 can also be one of our answers, because we can choose 3 positions here. That means we can put our 3 cows at these positions and their minimum distance will be at least 3. Okay, I hope this is clear, right? Now 3 can be our answer, so I will change my answer to 3. Now the range that we are left with is, we want to go on the right side now. Okay, we want to go on the right side now. So right now our mid is here. So now my start will point at mid plus 1. If you know binary search, I hope you know, because in the previous sessions I have covered that. So here we have 2, here we have 4, we have taken mid as 3. Okay, here we have start, here we have end. Now we want to go on the right, because the tendency is to go right. We want the more distance, as more as possible, right? Now what we will do, we will make our start point to start and mid plus 1. So start will also point here. So after that mid will also point here, right? Because if start is pointing at 4, start plus end, 4 plus 4 by 2 will be 4 only. So mid will also point here. So also we have found the solution for already, right? So we don't have to consider this case. So we have got our answer, which is 3. Okay, because 4 we have already covered this case, right? We have already covered this case. We don't have to take 4. So always we will take mid minus 1, not 4. We will take mid minus 1, right? So the answer is 3. So the answer is 3. We can only find that we can put 3 cows in these positions at a minimum distance of 3 only. The distance cannot be more than that. Okay, so the minimum distance will be 3. So have you guys got the answer? Have you guys got the approach what we are going to do? First of all, we will sort our array. The approach is we will sort the array. Okay, so that the positions come in increasing order. Sort the array. Then what we will do? Then we will take a range. Range will be, as we have sorted the array, maximum element will be at the end, right? So we will take a range between 0 to max element. We can take 1 to max element as well, because the minimum distance will be at least 1, right? Because if we have 1 to here, the minimum distance will be at least 1. So we can take from 0 to max, or we can take from 1 to max. It's your choice, right? Now, as we have taken the range, now what we will do is, in this question, we will first of all find the mid. Okay, we will find the mid, and we will try to see that if this mid can be our answer or not. Can we choose this mid distance? Like, we can choose C positions, let's say C is 3, C positions from this array, in which the minimum distance between these C positions that we are choosing from this array is at least this mid distance. Okay, at least this mid distance, and we will keep on doing this with some conditions. If we have found that this can be our answer, so we will go on the right, or if this cannot be our answer, we will go on the left. Because if this cannot be our answer, the greater elements cannot be our answer as well. If this is our answer, then greater elements can be our answer, right? So I hope this is clear. Anybody has any doubt in this? Have you got the approach? Now can we move to the code? Guys, any doubt? Anybody? If you want me to explain it again, I'll explain it again. Just let me know. Okay. Yes. Okay. Right. So let's write the code for this now, and then we will try run as well. Right. So let's write the code here. Okay. So if you have attended my previous lectures, okay. So the previous lecture that I did, I took a similar kind of question, right? I took a similar kind of question, but that question was a little bit like, the language was a little tricky. Okay, so just keep in mind that if you want to do binary search questions, they will be like this only. Their language will be very tricky, like find the maximum of minimum, find the minimum of maximum. So these types of languages will be there. So you have to think that, okay, these types of questions can be solved with the binary search. You don't have to cram, but it will come into your mind. Okay, so how can I solve it? How can I make the distance as large as possible? So we will think in a opposite way. Okay, so let's do this question. Public static, we want to return int, and let's say aggressive cows. Aggressive cows is our name of the function, right? And we will get a array, and we will get number of cows, let's say C. Okay, now what we have to do is, first of all, first step was to sort the array. Arrays dot sort, right? We will sort the array AR. Now what we will do? Now we will take the starting point and the ending point. So starting point was 0, right? And the ending point will be int end will be last element of the array, because it is sorted now. So last element will be maximum element. So arr.len -1, right? So start 0 and last element. Now what we have to do? Now, as same as binary search, what we have to do? While end is greater than start, right? Since n is greater than start, greater than equal to start. Okay, because when they cross, we have to stop that then only. So we since until end is greater than equal to start, we will keep moving just like binary search. It is the same thing. Okay. Now what we will do, but the conditions will be a little different, that if we will write a function if this is possible. That means first of all we will find mid. Let's find the mid. Int mid is equal to start plus end, start plus end by 2. Okay, we will write mid. First of all we have found the mid. Now what we want to do, we want to find that if this mid can be our answer or not, right? If this mid can be our answer or not, that means can we find mid can we select C positions from this array in which the minimum distance between any two positions is at least mid. Can we do that? So let's make a function for that. Okay, so if that function will return true, that means it can be our answer. Other Hi guys, hi, hello. Really sorry, there was some light issue, because of that Wi-Fi went off. So yeah, we can start now. Let me wait for the people to join, right? Hello. Hi guys, am I audible now? Sorry for the lag, and because there was some light issue, Wi-Fi went off, so that's why I disconnected. So now am I audible, everybody? Yeah, okay. So let's start. Okay, where were we? So first of all, what we did was we sorted the array. We took start, we took end, right? We took start, we took end. Now what we have to do is, we will see that until end is greater than equal to start, we have to keep running the loop. Okay, so we have found the mid as well. So let's take the same example, 0 to 9 we had. Okay, this is 0, this is 9. Now till when we have to run the loop? Till end is greater than, this is end and this is start. Till end is greater than start, we have to keep running the loop, and we will find the mid first. Okay, now we will see if 4 can be our answer or not. With the help of a function, we will make a different function for it. So let's write here is answer. Okay, we will make this function afterwards. Right now I'm just writing it so that we will get an essence is answer. Okay, so in this we will give it an array. Okay, we will give it an array, and also we will give mid, right? We will give an array mid and also the number of cows. Okay, not int, I am writing here, C. Here also not int C, it will be mid, and here also it will be array. These three things I will pass to is answer. If it returns true, that means this is one of our answers. This mid can be one of our answers, right? Otherwise, if it doesn't, that mid cannot be our answer, we have to go left. Okay, if this can be our answer, that means there may be a possibility between 0 to 9. If 4 can be our answer, so there may be a possibility that we can find a greater answer, right? That means we have to go on the right. If this cannot be our answer, that means we cannot go on the right, because we will not find any answer on the right. We have to go left. Okay, so we will make our start point to, if this can be our answer, we will make our start point to mid plus 1, right? We will make our start point to mid plus 1. Else, if this cannot be our answer, then we have to go on the left. So I will make my end point to mid minus 1, right? I'll make my end point to mid minus 1. Okay, and also I have to store my answer. If this can be our answer, then I have to store my answer as well. So int answer, let's say initially it is 0, and I will change its value. Okay, I will change its value to answer is equal to if this is an answer, so mid can be our answer, so I will make it mid. Okay, if mid can be our answer, this will return true. and if this returns true, I will make my answer is equal to mid, and also I will make my start point to mid plus 1. That means we will go on the right. Okay, what is this? Okay, we will go on the right. Now let's write this is answer function. What this is answer function will do, it will take my array, it will take my mid, and it will take number of cows, and it will find out that if this mid can be the minimum answer, if this mid can be the minimum distance between two cows, and we can find 3 positions, that means C positions for it. Okay, so let's try to do that. Is answer public static boolean, because we have to return true or false, is answer, okay, in which we will find int arr, int, that means an array, we will find the distance, let's say mid is a distance, and also we will find int cows, the number of cows we have to put, right? Now let's write this function. Let me just, okay, now we are going to write this function. How we are going to do that? So first of all, one thing you have to keep in mind, that we will always select the first element. Why is that? So let's say this is the array 1 2 4 8 9. Okay, so what is your chance of getting, let's say distance is 3, what is your chance of getting, and C cows is 3 as well. Okay, so what is your chance of getting the 3 cows placed in the 3 positions when you take first element, because this is the minimum element. So I will definitely put my first cow at the minimum distance as possible, right? It will always be there. Then you can find the distance, right? Because you want the distance to be as maximum as possible. If I take 2, right? If I take 2, so 3 cannot be our answer. If I start from 2, if I put my first cow on second position, so can we find 3 as our answer? Can we find the minimum distance between 2 cows as 3? No, it is not possible, because let's say 4 minus 2 is 2, right? So we cannot take 4. 8 minus 2 is greater than equal to 3, so we can take 8 only. Now 9 minus 8 is also less than 3, so we cannot take 9 as well. So we can choose only 2 positions in that case. But if I take 1, so then we can choose 3 positions, 1 4 and 8, right? Then 3 can be our answer. So we will always choose first position, because this is the smallest one, nearest one, right? And then we will find the distance, and as far as possible, right? We will find the distance as far as possible. So let's try to do that. So first of all, we will take a count, okay, and I will put in the count 1. Why I am putting 1 as the count? Because I am taking the first position. I am considering that one position has been taken. Now I'll take, let's say the first position that I am taking is, let's say let's name it answer 1, okay, and I will put ARR of 0 there, ARR of 0 there. That means I have taken this position, right? I have taken the first position in the consideration, and the count is 1. Why? Because first position has been taken, that means count has increased to 1. Now I will start from int I equal to 1. That means from the first index, I less than ARR dot length, and I plus plus. Now what I am going to do, what I want to find, just think about that. What I want to find is, I want to find a position. I want to find a position which is this distance apart. Let's say, let's take this array 1 2 3 8 and 9. Okay, 1 2 4 8 and 9. Okay, so first of all, I have taken this position. Now from this position, I want to find a position where it can be this distance apart. This distance apart, let's say distance is 3. I want to find a position which is 3 distance apart, at least 3 distance apart from 1. Okay, at least 3 distance apart from 1. So if I take 1 plus 3, then I try to find the position. 1 plus 3 is 4. So next position can be 4 or greater than this. Because first position is 1 and the minimum distance that I want is 3. So if I add 1 plus 3, it will become 4. So the next position can be 4 or greater than that. Okay, so the next position I want to find in this array should be, if answer 1, let's take it position. Okay, let's take position here. Position, let's say pause here as well, plus difference, position plus difference is greater than or equal to is less than or equal to ARR of I. ARR of I. Let me explain what I am trying to say here. Not diff, this is this. Okay, sorry, not diff, this is this. Okay, so what I am trying to say here is, if I took first position, I am always taking first position, which is 1. Okay, now what I want is next position should be 3 distance apart. So I have added 1, 2, 3, which is 4. Okay, so the next position can be 4 or greater than this. Next position can be 4 or greater than this. If I find this position, I will increase my count. So Deepak, I will answer that question. Okay, let me just complete it. I will increase the count. That means my count has been increased. That means I have got one more position. Let's say in this part only, if I want to find for 3, 4 can be found. If I found 4, I will increase my count, and now this position will be changed. Now this position will be 4. Okay, now this position will be 4. Why? Because the next position that I want to find should be 4 plus 3, which is 7. Can be 7 or greater. Can be 7 or greater. Because now I want to find the distance from 4, not from the 1. So I have to change this position as well, and I have to increase the count as well. Okay, I will increase the count, and also I will change the position. Position will be now ARR of I. Okay, ARR of I. Wherever I am, if I found that position, now the next position will be this. I want to find the next distance from this, right? Let's say I have found 1, then I have found 4. So minimum distance between any two nodes should be 3, right? So the next position will be 4 plus 3, which is 7. Can be 7 or greater. Can be 7 or greater. Okay. Now this is done. This is done. Okay. If at any point in this loop only, if at any point I find count equal to cows. Count equal to cow. That means I have chosen the positions at a minimum distance of 3, not 3 at a minimum distance of this. Okay, at a minimum distance of this. That means if at any point my count that I am increasing here, what is this count? I am choosing the positions, right? I am choosing the positions, and for whom I am choosing the positions? I am choosing the positions for cows, right? So if the number of cows is 3, and I found that the count has also become 3, that means I have found the 3 positions for the cows that we can put them in. Right? So that means at that point I will directly return true. Okay, I will return true, and also after that, if it doesn't happen, then I have to return false. Right? Then I have to return false. Okay, so this is done. The question is done. We have written the is answer question is answer as well. We have written aggressive cows as well. Okay, now what we have to do, we have to call this function, and also we will dry run it. Okay, right? So this is how we write the question, how we do binary search question. Most of the binary search question we have to do this way only. Okay, so this is a lot of S here. Okay, so first of all, let's run it. Let's run aggressive cows. So system dot out dot print. Okay, aggressive cows, right? And I will pass what I want to pass, the answer that we know. Otherwise you can pass any array. Answer int, let's say ARR1 is equal to 1, 2, 8, 4 and 9, right? Now let's pass ARR1, and the number of cows will be 3. Okay, so the answer here should be 3, right? So let's try to run it. There may be some error. We will do it properly. If there is some error right now, let's try to find out. Okay, let me just comment this and comment this, right? There is an error. Okay, so let's see what is the error here. So there is some unresolved compilation problem at return a result of type int. Okay, somewhere I haven't returned a result. Okay, let me just see that. Okay, so aggressive cows, I haven't returned that result. Okay, return my answer as well. I have to return my answer as well, right? So now I will return my answer, and the error will go away. So let's run it now. So you can see that the answer is 3, and the answer is correct, right? So why I have chosen this approach? Why can we not do any other approach? So let's try to find out the answer for this first of all, that why cannot we use any other approach. So let's say the question is 1, 2, 3, 8 and 9. Okay, 1, 2, 4, 8 and 9. So if he says that you have to choose 3 cows, you have to choose 3 positions as far as possible. So what you will do, like simple approach, brute force approach can be, you take first position here, okay, then you will go forward and you have to find for each position, like you have to go and you have to see that each position, you have to consider all the possibilities, right? You have to consider all the possibilities, and let's say if the array is of size 1000 and you have to choose, let's say 3 positions, then the possibilities can be infinite, right? So this will go in the exponential time complexity. You will keep on choosing, you will keep on choosing, you will keep on choosing, right? It can be very, very high time complexity. Okay, so that's why we will not use that. It can be, because it will depend upon the number of cows we want to choose. So there can be hundreds of possibilities, right? So you can choose this position, this position, this position, right? You can choose this position, this position, this position, this position, this position. So there can be a lot of confusion in that, and a lot of possibilities will be there. So time complexity will be very, very high. But in this case, while we are using binary search, what will be the time complexity here? What will be the time complexity? If you have seen my time complexity lectures, you will see what we are doing here. First of all, we are sorting the array, n log n. Okay, n log n will be the time complexity. It is big O of one operation. This is also big O of one operation, big O of one operation, right? And this is binary search, right? Binary search, how much time binary search takes? Log n, right? Log n time. But here we are calling a function as well. Every time, whenever we are running the binary search, we are calling the function. So let's see how much time will function take. Okay, how much time will function take? So maximum this function can go on each element of the array, right? So it starts from here and we can go on each element of the array, and we want to check every time, we want to check if there is a position. Okay, if there is a position here, here and here, if there is a position that is at minimum distance from the other position, right? So we can go on each element of the array. So that can be big O of n, right? Big O of n every time. Every time whenever we are calling this function will take big O of n time. And how many times we are calling this function? As we know this is a binary search, we will call maximum of log n time. Okay, and every time log n times we are calling a function, that function is doing n operations. So the time complexity will be big O of n log n for this, and also for sorting big O of n log n. So total time complexity will also be big O of n log n. Okay. So as you have seen in the previous that we have seen, the time complexity can be exponential as well, right? But in this case, the time complexity is only big O of n log n after sorting and using binary search. That's why sorting and binary search makes questions very, very easy, right? It makes questions very, very easy, right? So we have seen the answer, we have seen the time complexity. Now let's dry run it. Okay, now let's dry run it, the last thing. Okay, bro, can you teach dynamic programming? Yeah, I will teach dynamic programming. As we are moving forward, we will cover everything. We will do dynamic programming as well, but before dynamic programming, you should know recursion, right? So we will do those lectures as well. So could I add guided projects on my resume, or I do? See, if you know about your project, even if it is guided, if you know about the project, you can put it there, because interviewer will just ask you to explain it and what technologies you have used. Sometimes he will, like, let's say you have used some API there and you don't know how to make an API, what is API, so you will be like, you will not be able to answer that and you will not get selected, right? So you should know every detail of that. If you know the framework, whatever you are using there, the technology you are using there, and you know how to make APIs, these things, so you can put the project even if it is guided. Otherwise, don't put it if you don't know about anything about the project. It is not just that they will see the project and they will select you, they will ask the questions and they will see that how much work you have done. So among Amazon and Adobe, whose difficulty in DSA round is higher? So I'll say Adobe. Why? Because Amazon asks questions if you have done the whole DSA, right? Even if I'll say the level is same, not much of a difference. If you have done the whole DSA in both the companies, you will be able to crack them. Okay, you will be able to crack them, not a problem. But do DSA very properly, right? So now let's dry run this question once again. Let's see if there is any other example there that is given to us. Okay, So you can try this question here as well on Spotch. Okay, this is aggressive cow question. You can try it here as well. Let's see if there is any other test case given to us for which we know the answer. There is no other. So let's take this one only and we will try run it. Okay. So let's say 1. Let's make our test case. Okay. 1, 2, 5, 7, 13. Okay. Let's say this is the case. And what can be the and the C here, the number of cows we want to put is 4. Let's see that. Can we put 4 cows here, and at what positions? Like what will be the minimum distance between these 4 cows if I want to put them in these positions, right? Let's see that. First of all, I will sort it. I have already taken a sorted array, so we don't have to sort it. Now we will start from 0. Our start will be pointing at 0 and the maximum distance can be 30, right? Now what we want to do, first of all, answer will be 0. Our answer will be 0. Now until end is greater than start, we know the for binary search end should be greater than equal to start. When they cross each other, we will stop. First of all, we will calculate mid. 13 by 2 will be 6. So first of all, we will try to find out the solution for 6. That if 6 can be our minimum distance between 4 cows. Okay, 6 can be the minimum distance between 4 cows. So now we have mid is equal to 6. So if is answer will give us true or false. That means it can be our answer or not. Okay, it can be our answer or not. So let's go down and we will see that if this can be our answer or not. Okay, let me erase it, and I want to find out for 1, 2, 5, 7 and 9 and 13. I hope this was the solution. Not this was the, right? This was the array. Let me just see that. What was the array we had? The array was 1, 2, 5, 7, 13. 1, 2, 5, 7, 13. Okay. 1, 2, 5, 7 and 13. Right. So now what we have to do is, first of all, we have passed this array. We have passed the distance. Distance is 6 right now. And we have passed the number of cows. Number of cows here is 4. Right. We want to find 4 positions. And we want to see that if the between those 4 positions, minimum distance can be 6 or not. Minimum distance can be 6 or not. Right. So now the count is 1. First of all, I have taken this position, that this will be definitely 1 position. Right. Now what we will do is, we will see position plus 6. Position 1 plus this distance 6. The next element can be at 7 or greater than 7. Right. Next cow we can put is at the position 7. That means on the 0th index plus the distance is 6, can be less than equal to array of 5. Okay. It can be less than equal to array of 5. That means the next position that I want can be 7 or greater. Okay. So I cannot take 2, I cannot take 5, it will keep on moving. I can take 7. It can be 7 or greater than 7. So I will increase my count, it will become 2. Now I will go to the next position. Now I want to find the distance from this. Right, 13 minus 7 is 5. So I cannot take 13 as well. So in this part, we cannot reach 4. Why? Because we want 4 positions, but we are only able to get 2 positions, 1 and 7. Right. So we cannot, in this part, we will return false. Okay, in this part we will return false because count that we are taking here is not equal to cows, so it cannot return true, it will return false. Right. So when it will return false, here we will get to know that it has returned false. That means 6 cannot be our answer. Right, 6 cannot be our answer. So if part will not work, we will go on the end part. Okay, else part. So that means our end, start was at 0 first of all, 13 was the end, and mid was 6. Now what we have to do is, our end will become mid minus 1. Now our end will become 5. So it will be between 0 to 5 only. Our start is here, our end is here. Right. Now again we will find the mid. 5 by 2 is 2. Right. Now we want to find out if 2 can be our answer. That means minimum distance between 4 cows. Here we have taken cows as 4. Right. And minimum distance between 4 cows can be 2 or not in this array. The array is 1, 2, 4, 1, 2, 5, 7 and 13. This is our array. Can we find 4 positions with minimum distance as 2? Can we find that? So again it will go to is answer part and it will again find out this. Okay. Let's find out if 2 can be our answer or not. So let's write it here. 1, 2, 4, 1, 2, 5, 7 and 13. For this array, can be our answer? So here we will first of all select 1. So 1 plus distance. 1 plus distance is 2 right now, right? 1 plus distance is 3. So next element can be 3 or greater. Okay, next element can be 3 or greater. So 2 cannot be our answer. 5 will be our answer, right? So we will increase the count, we will make next position as 5. Now what will happen? 5 plus 2, next position that we will found will be 7 or greater. So we have found 7. So 7 can be our answer. Now again we will increase the count. First of all it became 2, now it has become 3. Now when we have chosen 3 positions, that means 1, 5 and 7, we have chosen 3 positions. Now what we have to do, we will go to the next element, which is 13. We will see that if 13 minus 7, the last position we have chosen, and the distance between them is greater than 2. Yes, it is greater than 2. So we can choose 13 as well. So now our count will increase, it will become 4. And you can see here count should be equal to cows whenever it becomes 4 and the cows were also 4. So if they are equal, we will return true. That means we have found 4 positions in which the minimum distance can be 2. Okay, so the in this part it will return true. That means 2 can be one of our answers. 2 can be one of our answers. So here we will get 2 as true. So we will go inside this if part. So before what we were doing, from 0 to 5 we were finding. Now we will make answer as mid. Now our answer will become 2, and also start will become equal to mid plus 1. Mid was 2. So now start will become 3, and we will find the answer now between 3 and 5. Okay, this is the last iteration. In this part what we will do, again we will find the mid. Right now our answer is 2. We will find 4. Right, now we want to check for 4, if 4 can be an answer or not. So I am just directly telling you guys, you can try it by yourself. 1, 2, 5, 7 and 13. In this case 4 can be an answer. So we will choose 1. Next position should be 4 apart. So we can choose 5. But we cannot choose 7, right? We can choose 13 because 13 minus 5 is greater than 4. So we can choose only 3 positions, not 4 positions, right? So again it will return false. That means 4 cannot be answer. So now we will find the answer between 3. Like only we have to check for 3 now, right? So you can try run it by yourself as well. So answer at last you will get is 2 only. 3 cannot be our answer as well, right? You will get only 2 as the answer. You can run it as well. Let's try to run it, and you will get the answer. Okay, so just try run it by yourself, then only you will be able to understand it, how binary search is working and how everything else is working. So 1, 2, 5, 7 and 13. Okay, so let's try this, and for the 4 cows, so answer should be 2. Answer is 2, right? So 2 can be an answer. You can try run it properly by yourself and you will get that. Okay, so I hope you have got whatever I have told in this session. This was one question, very important question that we have done. Okay, these types of questions are only there that you will find for binary search. None other questions will be there for binary search. These are very good questions. Okay, in the previous session I have covered one question which was very good. This is also very good question. Okay, tomorrow also we will do some questions. The day after tomorrow also we will do the questions, because this part is very important for binary search, for sorting part. This is very important. This is also, you can see, a greedy solution as well. Okay, greedy means that I'll tell you what is greedy and DP. These are two different terms, right? So I hope you have got today's session. And also, what was the question? Will I be able to crack DSA round or Adobe from your DSA course? Yes, you will be able to. Just follow along. Just do all the things that I'm telling. Also practice some questions from different platforms. Let's say you have done arrays, try some questions. You have done strings, try some questions. Arrays like these also, try some questions. Keep doing the questions, because then only you will be able to do it, right? Questions, like practice is the most important thing in DSA. Learn and practice, and also go join this Telegram channel so that you will get all the information. Okay, and also like, share and subscribe. This is very important, so everybody will be able to get the content we are putting here, and also you will be able to get the information that okay, this lecture is live, now this lecture is live. Okay, sir, I have 4 years gap. Sumandata. Okay, not a problem. If you have just started, see, right now there is a boom in the IT industry. Everyone is hiring. Okay, even if you are 4 years of gap, if you have knowledge, you have coding skills, any company will hire you. Just you need to give the genuine reason that why there is a 4 years gap. You have to specify this in your resume. They will ask you. You have to answer that confidently. If you have cleared all the rounds, okay, of technical rounds, you will be able to do that. Yes, there are a number of questions there on net. Yes, I can give not the list actually, but the question that I am doing here right now, you will find, you cannot find it because I am taking from different sources. I'll try to do that. I will try to give you the questions, number of questions that you can do, but also the question that I am doing in the class, that also go and try them. They are very, very important questions. They will cover all the concepts. Okay, if you have covered my Java lectures as well and also these DSA lectures, you will get to know that all the questions are very, very important that I have covered. And in the future sessions as well, I will take only those questions that will be helpful in every other question as well. Okay, so just follow along all the questions, right? So anybody has any doubt in today's session? Is that question clear? And just go along, like do the session again, just see the session again if you have any doubts. Okay, because this question is very, very important and this is very famous question as well. Okay, thank you very much everyone for joining in. Let's meet tomorrow and we will do some more questions, right? Thank you.